in this video is to walk you through the solution of the first two lab exercises, or I'm sorry, the first two problems that are assigned in Lab 1 in Computer Science 201 course that I'm teaching in winter 2011 at Cal State San Bernardino. So here is Lab 1, and you'll see it has learning objectives and other sections, and here are the instructions for Lab 1, and you need to do 4 problems. So you're going to solve 4 programming problems, and after you solve these problems you will store your solutions into a Subversion repository, and I will have already set that up for you. If I haven't sent you an email about that, then please speak to me or my lab assistant to get that set up for you. And then after you submit your work to the repository, then I want you to fill out the Lab 1 report, which you do on Blackboard. Alright, so there's different ways of doing the lab, and in this video I'm going to show one possible way, which is to write the programs, compile and run them in the Linux environment on one of the lab machines. But we're going to do that remotely, so we're going to be working in Windows, but we'll establish a secure communication channel with one of the lab machines, and we'll work on Linux. So we'll work through what's called a console window, or a terminal window that we start in Windows. Now for that to work, I want to show you that I have some links here under CSE 201 Windows Notes, and this is information about how to work on Windows in different ways. This section here on compiler, we don't need that for this video. We're not going to be compiling the code locally on a Windows machine, so we don't need that. As well, we will not be committing from a file system on our local Windows machine. We will be committing into the repository from a remote Linux computer, so we will not need a local version of Subversion. We need the version that's on the Linux machine. However, we will need the tool that's described in this third section called Secure Shell. And specifically what we're going to use in this video, what I'm going to use in this video anyway, is a program called Putty. There are alternatives. This is just the one that I use. It's widely used, so it's a good tool. And there's another optional tool that you could get called WinSCP that'll let you do file transfer very conveniently between Windows and a Linux system. But we will not need that for this video. We only need this tool here called Putty. So you can get that from here. As you see, there's a download section in here, and you can read through this and install Putty. Okay, let's get back to the lab and let's see what it is we need to do. This is Lab 1. And so our first goal is to solve this problem, P11. That's on page 29 of the textbook. And to solve this problem, what we need to do is to write a program, and that program will be stored in a file. The name of the file will be main.cpp. So this is actually the layout, the hierarchy of folders and files that you will end up having when you solve all the problems in this lab. So as you can see, you have this top level folder. This is a folder or a directory, and we're going to use the name CSE 201. Under that folder, we're going to have a folder for each of the 10 labs in this course. So we're in Lab 1, so we'll create a folder called Lab 01 under CSE 201. And within each lab folder, we're going to also have a folder for each programming exercise. So there are 4 programming exercises that comprise the first lab, P1.1, 1.2, and so on. And in the naming, I'm replacing the dot that appears in the book with an underscore, because the underscore, well, the dot will work as well, but the underscore I find is convenient because it's different than the dot that separates a file name from its file extension. Here we have a file called main.cpp. The file name is main, and then there's a dot, and then it's followed by this 3-character extension. Okay, so let's get started by logging in to the remote system. So I'm going to start up this program, Putty. I have it installed already. And you need to enter in a host name. A host name is the name of a computer. It's the address of the computer on the internet. So the name that we need to use is jbh3-1.csc.csusb.edu. And this is a single machine that gives us access to the Computer Science and Engineering network at Cal State San Bernardino. So this is what we're going to be connecting to. So I'm going to click open on that, and it asks for a username, and I am Turner, and then a password. And you can see it's showing when you log in, it gives you this suggested list of systems, internal systems that are available. So now we're logged in. It shows in the prompt here, it shows that we're logged into this machine, JBH3-1. We don't want to work on that machine. We want to, because a lot of people may be logged into this. In fact, we can even look. If I type in users, well, I happen to be the only one logged in now. But typically there's going to be several people logged into this machine. We don't want to run the compiler and the editor on this machine. We want this machine just to be a transfer point. So we're going to end up opening up another terminal window within this terminal window, using this SSH command. So it's SSH, and it would just randomly pick one of these, and I'm going to say use this one right there. So this is the room number, JB359. That is in fact our lab room, and this -4, so that's one of the computers in that lab which is currently turned on, and we can work on that computer. So I highlight this and I right click. That does a paste. And I don't need the fully qualified domain name like this, because the JB359-4 is on the same network as JBH3-1, so I can omit this. Also, my user name is the same on JBH3-1 as it is on JB359-4, so I don't need to include that either. If it was a different username, then I would need to do that, which I don't need. So once again, it's pretty straightforward. Just SSH onto that one machine. My password again. And now I'm in. Now it drops me into something called my home directory, and that's signified by this character here, tilde. And we also see in the prompt that the prompt, this is called a prompt, a command line prompt. The prompt is a character string that gives some useful information, and then we have a place to type in text, so that'll go in here. But in the prompt, the useful information is, let's take a look. There's my username with an @ symbol, Then there's the host name, and that's JB359-4. As you can see, the previous host name in the previous prompt was JBH3-1, so we know we're on a different machine or a different host. And then the other piece of information is the current working directory, which in this case is my home directory, which is called tilde. Tilde is the kind of it's a shorthand version for your home, for your current for your home directory. So if I want to see where I am in a file system, I can type in print working directory, hit enter. So this shows a path where my home directory is in the file system. The top level folder is U. Under that is another folder called faculty, and under that is a folder called Turner. That is my home directory. You will have a different home directory, and when you log into the system with your username and password, you'll be dropped into a different location. Alright, in here, the first thing that you need to do is to create a folder to store your work for this course. So I'm going to make a directory, mkdir. It's the same command in Windows, by the way, and also Macintosh. I'm going to make the directory CSE201. Done. Now we're going to CD into that folder. So it's CSE201, CD CSE201. I hit enter. Notice that the prompt has changed. Before I was in tilde, now we see CSE201 because my current working directory is now different. So if I run that command again, pwd print working directory, it shows we're down one level. This is the folder that we just created, and this cd command, that's change directory or current directory, we use that to change to to make our current directory something new. Alright, now that we're in this CSE201, we can make another folder called lab01, which we do. Let me just check on that. That's what I asked for, right? Lab01, and then another folder for the solution to the first exercise. Once again, make directory a third time, P11, and let's CD into that. I want to show you a shorthand here. I'm going to type in a P, and I don't need to type in the rest of the characters. I can just press the tab key and it does command completion for me, because it tries to match with the name of something in the file system, which it finds an unambiguous match, P1_1, so that's what the system types out for us. Okay, so here we are once again. We've really drilled down. We're quite a few folders deep in the file system at this point. So now we're going to create our first program. It's going to be it won't be the complete solution to the first exercise. So what we're going to do is develop the program incrementally, which is how I recommend that you work in this course, is to write your code in steps, and where each step brings you a little bit closer to the final solution. So that's called incremental development. We're going to use a tool called VI. I type in VI and then the name of the file that I want to create, main.cpp. Hit enter. And this is the VI editor window. We're no longer at the command prompt anymore. We're now in the VI editor. As you can see, there's some tildes down here. There is information here about what line number and column we're at. There's the name of the file that we're editing right now, and so on. Now, this editor can be a little tricky to learn because it's not a graphical. It doesn't have a graphical user interface. It's a character-based program. Now, one of the benefits of using this particular program called VI is that it's pretty much by default installed on every type of Unix system. So if you're on Macintosh, you'll see if you have a Macintosh, VI is installed. You'll be able to open up a console window or terminal window and type in VI and get this program running there. Also, on all the variants of Unix, including Linux, VI is by default available. There may be some exceptions there. It's not available on Windows. If you want to run VI on Windows, you need to get it, install it, and use it. So it is a useful tool to do system administration. It's useful for working in the mode that we're now working, which is remotely. But it's got a difficult syntax to learn. It's not that difficult. There's a lot of commands, but you really only need a small subset of all possible commands. And that small subset is relatively easy to master. So let's start. I'm going to press I, and that puts me in insert mode. I press the letter I. Now you see that down here in this status area, it now says insert. We're in insert mode, so we can type in characters at this point. I'm going to type in this sharp sign, include. This is called a compiler directive, and it'll be IO stream with angle brackets. You can see it's color coded, and then another command using namespace std semicolon, and finally we need to type in the main function. So it's int main int argc, and then char pointer args, and that's an array. So this is called a function. The name of the function is main, and the function returns a value of type int or integer. And the function takes two arguments. They're separated by, and the two arguments are separated by this comma. The first argument is of type int or integer, and its name is argc. The second argument has a name of args, and that second argument is an array of char pointer. Now, functions is a topic in chapter 4. I'm just going to mention that about what main is here at this point, but we're going to delay any further discussion or analysis of functions until a later chapter, chapter 4 in particular. So we need this function, and everything we write is going to be between this opening and closing brace. So I'm going to tab in. You should always use indents to show the structure of your logic. So the command that we're going to execute now is called is the output operator. So we're going to type in the following line. It's cout with two angle brackets, and then say the word hi in quotes, and then a semicolon. So cout is a symbol that represents the standard output stream, which by default is the display or the console window. And this is an operator. It's called the output operator in this case, because it's being used with the output stream. And then we're passing in a string. And strings, this is called a string literal. It's not a variable. It's a constant string with the characters H and I. And these type of strings are enclosed in quotes. So the compiler needs to know where the string starts, where the string ends. We want to have, when it prints HI, in the console window, we want the cursor to go down to the next line. So we're going to also output an end line. By the way, the book does something a little differently. The book shows this as \n. That works as well. That's a control character called a new line. But I'm going to use this form here, which is to print a new line using that method. So I'm going to, oh, did you see that? I have the insert, I'm in insert mode, right? So we're in different modes when we're using VI. To leave insert mode, I press escape. Okay, now the file is not saved yet. It's just in main memory. So I need to do :W. And W is for write. I'm going to write the file. And look at it. It shows it down here in the status area that main.cpp is now written. And now that it's written, we can quit. So I'm going to do, just pay attention to that. That's backspace to cancel that. I can do : to get the command prompt here, right? And then I hit backspace to get out of that. So I can go : and then we get the command prompt, the VI command prompt. We could type in commands, such as the write command. That's one, right? So : another command is to quit. So it's :Q. If I hit enter, I exit VI. Now we're back to the terminal window. And if I want to take a look at, I'm just going to hit enter here, so it just makes some blank lines. I want to take a look at the contents of our current working directory. So pwd, print working directory, shows where we are, but we don't know what's inside. We know that we're inside p1_1, but we don't know what files are in there. So I'll use ls to show what files are in there. There it is, main.cpp. So we do have one file in there. Now, what we're going to do here is to compile. So to compile this file, we type in C++ space main. To use the tab key to do command completion. And I hit enter. And see, it just quietly completes. That means there's no errors. If I do ls again, you'll see that the compiler generated this file a.out. That's an executable file. And so let's go ahead and run that. Now to run a.out, I need to provide the path name to the file, followed by the file name. Now, the file is in the current working directory. So the path to the current working directory is /. The dot means my current directory, current working directory, that's good enough. And then the slash is the separator between names in a file path name. So the folder that we're in is dot, or the current folder, and then we're going to end it with a slash, and then we're going to type in the rest of the file name here. It's a.out. So if I hit enter, it runs it. We'll see we have hi there. Let's go and change that to by, just to see that we can make things, that we can modify the code. What's the process of modifying the code? So I'm going to use the up arrow. And the up arrow lets me scroll through what's called a command history. And I'm going to go up until I get to the command vi main.cpp. Now I can hit enter to reissue that command from the command history list. There it is. There's our program in VI. I'm going to press I to go into insert mode again. I'm going to tab over, not tab, but arrow over to the right here. Then I'm going to press backspace. Then I'll type in by. And then press escape. Then :W to write. But in the same time, I'm going to also write and quit. I'm going to write and quit, which I can do at the same time here. Write and quit. And let's use the command history to reissue the compilation command, C++ main. I hit enter. And now we're going to reissue the command to run that executable. And you'll see that it now says by. Okay, now what I'd like to do is to show what happens when you have a mistake in the code. So let's go back in to the program, And let's introduce a syntax error. Let's suppose that we left out that quote right there. And then we're going to write and quit. That's called a syntax error. We're not properly, correctly delimiting the string BYE. So I'm going to write and quit here. Let's run the compiler again. And you see we get error messages. So it starts with a warning and missing terminating quote character. That's a warning. It shows the line number here 7 and also shows a column position within that line 15. And then there's an error here on line 7, and it says that the terminating quote character is missing. It's a little odd there because first it's exactly the same comment, missing terminating quote character. It's exactly the same comment, but in this case it's listed as an error, shown as an error. In this case it's shown as a warning, so I'm not sure why it's doing that. And here looks like there's a problem with the character set. There's some problem that the system I'm using on my end, maybe the SSH program I'm using here, is assuming a different character set than what's being sent from the remote host. And so I think this probably should be a quote. It's coming up with as an A hat, and same here as well. Anyway, we know what the problem is. Missing terminating quote character. Let's go in and fix that. Yeah, let's go ahead and put that in there. And it's insert mode quote, escape to leave or insert mode, then colon WQ, write and quit on the compiler again. Now we have a silent success. It doesn't say it succeeded, but if it says nothing, that's good news. No news is good news here. So ./a.out. Now it says bye. That's great. Okay, so now what we're going to do is show how to put this solution into the source code repository. Now to do that, I'm going to go up to the folder CSE 201. So I need to I'm down 2 levels underneath where I want to be. So to go up, we use this version of the cd command. I go cd and a space with ... Remember, dot means your current folder, and ... refers to your parent folder, the parent of the current folder. So if I cd to the parent, you'll see that in the prompt we used to be at p1_1. Now we're in CSE 201 like that. But something is wrong. Something is wrong. P11 should be in lab 01. So if I look inside, if I use the ls command to look inside lab 01, ls is short for something like list of contents of lab 01, you'll see there's nothing in there. But if we list the p1_1, it shows 2 files. So there's a problem. I need to move p11 to be under lab 01. That's the structure I'm asking for here. I want main.cpp inside p11 and p11 inside lab 01. So we use the move command, which is mv. So we move lab 01, and you see the slash comes up here. And it's not needed. You can put it there. It's just, I used the command completion. I used tab to do command completion and added a slash there. And it's not needed in this case, but it's not a problem to leave it in there. So we're going to move. Oh, we don't want to move the lab. We want to move the folder p11 into the folder lab 01. So we're moving this folder into that folder. That's the form of the move command that we use. I'm going to hit enter on that. And then if I use ls now, you'll see there's only one folder. Let's look inside that folder, ls lab01. There it is. Inside lab01 is p1_1. And if I hit tab here, I get command completion as well. And I can inspect from my current location in the file system, CSE201, I can inspect what's inside of a folder 2 levels down. So I use ls with that string right there. I can see that I have those 2 files. In fact, this a.out, as you remember, this was automatically generated. And so we don't need to keep it, we don't need to hold on to it. We can clean up, we can delete it. So I'm going to delete that. I'm going to use the remove command, rm, to delete a.out, because we can easily regenerate it. And I don't want to put a.out into the repository. So I'll remove, and I'm just going to hit the tab key. This is only one folder in my current working directory, so it matches against that one and only one folder. I'm going to continue with the tab key. Oh, now when I hit tab key, there's an ambiguity. Under p11, there are 2 possible choices, a.out and main.cpp. So I'll give the system a little bit of help by starting the string with a, and now when I hit tab, it knows to match against a.out. So once again, we're deleting this file with the rm or remove command. I hit enter. Let's check. I'll use the command history to look inside that folder again. Now we see that there's only main.cpp in there. And we're positioned in our CSE201 folder, and this is where I want to start the repository. So I created an empty source code repository for you, and you will have gotten that information by email, which includes a username and password. So at this point, what I want you to do is to check out that empty repository into this location. So we're going to use svn for subversion, and then co for checkout, space, and then the name of the repository and the folder within it. So let's go back to the lab, and there it is. This is the name of the repository, and something close to what your username will look like. So I pasted it in there. You'll see it's https:// there's an IP address there, and another colon, and a port number, and a slash, and then it's your Subversion username. But I'll put my Subversion username in there. You'll have to use the name I give you. So David Turner _ Linux. That's the name of my repository, and I'll enter that command. And there it is. We checked out version 0, so nothing is in there yet. Now if I do ls to see what's inside my current directory, you'll see that there's davidturner.linux. So that is not right. I'm going to have to clean that up. So I'm going to look inside there, and I see that there is nothing. I'm going to remove that. This is not what I wanted. I cannot remove David Turner Linux because it says it's a directory. Let's go ahead and try to remove it using remove directory. This will fail as well. I'll just show that to you. It says it's not empty. Cannot remove the directory because the directory is not empty. Now why is it not empty? If we look inside there, we don't see anything. The problem is what's in there is hidden. We want to reveal the hidden objects in that folder. We need to use this -a option with the ls command. There it is. There's this .svn subfolder in there, and this is what's wrong. So we're going to remove that, we need to use a dangerous command. You have to be careful about doing this. I'm going to use a -R for recursive, and then I'm going to type in the name of the folder that I want to delete recursively. That means delete this folder and all of its contents. And it's asking about, are you sure? And I'm going to say yes on that. So there we done. We've cleaned it up. Now I'm going to try this again, because I don't remember exactly how to do it. I think what I needed to do was at this point, I needed to enter in a destination. So I'm going to use dot here. It's a little slow. Still looks a little funny. Looks good. Alright, just needed that extra dot. That meant the current working directory. And now let's do the same thing now. So inside our current folder is just a slab01, but actually if we use the -A flag on that command, you'll see that there's another folder called .svn. We can look inside of that and see that it has other subfolders and other files. So these blue names are subfolders, these white names are files. This means current and this means parent. And so this, you should never operate directly on an .svn folder unless you want to simply delete it, which I showed you before. Because this is the control information that the Subversion command line client uses to store information that it needs to keeps the current version, what's called the working, what do they call it, the working version of the repository. It needs to keep the working version of the repository synchronized with the remote version of the repository. So let's now there's nothing in the repository at this point. I'll prove that to you, and you should try this exercise yourself. Let's get the URL, paste it in there, and let's take a look. So David Turner and Linux. Once again, you'll need to use your own name for this. The site security certificate's not trusted. I'm going to proceed anyway. I need to type in my username and password. David. Now, I used this username David Turner, but you'll use, which is different than what I have up here, David Turner Linux, but you'll have your username that you use to access the folder will be the same as the username you type in here. And then my password, just to and you'll see I'm at revision 0 and there is nothing in there. Let's go back here, let's put something in there. So I'm going to use this svn add command, and I'm going to add lab01, and it shows 3 additions, and it has a next to each one. So lab01 is a folder that will be added. Lab01 has a subfolder p11 that will be added. p11 in turn has a file within it, main.cpp, which is also scheduled to be added. So 3 things are scheduled to be added. They're not actually in there yet. If I go back to the web page and hit reload, you'll see it's still revision 0. We need to, in fact, commit the changes. So we use svn commit. We don't need a space, but I'll put it there. Hit enter. And we have an error message here. And what it needs to do, actually, when you commit changes into the repository, it wants some documentation, some text that's added to you can use to describe what you're committing into the repository. So, and what it does is it launches an editor that you use to type in that comment. But we can configure, using one of these environmental variables, we can configure the editor But I think the easiest thing to do at this point is to type in the comment directly on the command line using -m, and I'm going to put in an empty comment. So it's just an empty string, right? It's just so this is a string that says hi, and then this is a string that has nothing in it. It's called an empty string. So let's commit, and there it is, done. And it added 1, 2, 3, and it committed revision 1. Now if we go and check, hit refresh, there it is, revision 1. Lab 01, p1_1, main.cpp, you can see everything is there. Now this, by the way, doesn't solve the problem. It's a partial solution, and we need to keep working to get the solution that we want. I need to complete the exercise that's in the book. We just have a stub right now. I'm going to use VI, and it doesn't quite solve the problem as stated in the book. Let's go ahead and do that problem. And what we need to do there is print, hello, my name is Hal. Hello, my name is Hal. And we need another line, which is, what would you like me to do? I'm going to copy this line. I type in YY. And then I'm going to, then YY, I think Y stands for yank. You're yanking the current line into a buffer, or into, a buffer is another word that they use for this concept of a clipboard. So we have a number of different buffers. There's a default buffer. By YY copies the current line, where the cursor is, into the default buffer. Now we can paste out of a buffer as well. If you want to paste out of the default buffer where the line is, you just press P. So I'm going to press P, and there's the paste. And now I'm going to delete. I'm going to use the X key. X is delete. And now I'll go into insert mode, pressing I, and I will type, what would you like me to do? What would you like me to do? And I'm going to press escape. I'm going to save my work, so it's :W to write it out. And then we get a value. So we have to declare a string called, I think they call it user input. So we're declaring a string called user input, and then we use get line, get underscore line, oh no, no underscore, get line, cin, that's a standard input stream, which by default is the keyboard, although we can change that, user input, and finally we need to print. So this, by the way, this get line, this reads from the standard input stream or the keyboard. It reads a string and places the value in user input. So what we're going to do here is we need to say, I am sorry, cannot do that. I'm going to copy these other lines. So I'm going to leave the insert mode by pressing escape. Go to here, YY, so I'm going to yank the current line into the default buffer, P to paste out of the buffer, and there we have it. And then I'm going to use X to delete. I'm going to just hold down the X key. Now I'm going to go back into insert mode, press I. I am sorry, I cannot do that. I am sorry, comma, I cannot do that, period. I pressed escape to leave insert mode. I'm going to do :WQ, enter. Let's run the compiler, C++, main, use the tab key, enter. Looks good. /a.out. Hello, my name is Hal. What would you like me to do? I'll say nothing. Enter. I am sorry, I cannot do that. Okay, so now P11 is in fact finished. Please notice that in this folder we have a.out. I also want you to notice that if we add in the -a to reveal the hidden files as well as the visible files, that we'll see that there is a subfolder called .svn, which contains the information the Subversion client needs to keep the current working the image in sync with the repository. So I don't want to commit a.out. So what we could do is we could just remove this. But the other thing which I would like to do is to, just for convenience, tell the system that that I don't want a.out to be listed as a file to be placed into the repository. So I'll do that using a command which seems a little complicated, but I'm going to use it anyway. Let's see, I'm going to find that command. Let's see if I have that somewhere. So I'm going to look for that command, and it's on my home directory somewhere. I mean my home page. Okay, I've made an addition to the web page here. So if you go back to CS to the web page, then I'll go into the first lab, and there is a link to CSE 201 Subversion command line notes, and I just started to put in some notes here. And here is a section called ignoring names. Here's a command that you can use to tell the system to ignore a.out in the current folder. And there may be a way, this only affects the current folder by the way. There may be a way to hit all your folders at once. I'm going to type that in there. And so it says, warning, this is not under version control. I think that's okay. The warning is good. We don't want a.out to be under version control. We want a.out to be excluded because a.out is a derived file. We can easily produce a.out from main.cpp. So derived objects as a rule should not be stored in source code repositories. So now that we have that in there, what we can do is do svn add, and it's main.cpp. Sorry, it's already under version control. Okay, so we're already set there. So what we do is we just want to commit our changes. Now before I hit enter on Svn Commit, I want to show you that we're here, we're in our repository. This is the previous version. So we've been modifying the program on the, in our home directory. But what we're looking at here is what our code looks like in the source code repository, which we have not yet updated the repository with our changes. So the commit command in fact does that. So I'm going to hit enter on that, and it's complaining again, and I forgot once again we need to add a comment minus m, and then I'll put an empty string there. Okay, there it is, sending main.cpp. It's committed. Now we're at revision 2, by the way, please notice that. If I hit enter to refresh this URL, you'll see that now we have the current version of our code in the repository. So that's how you should work. You can intermittently commit changes into the repository while you're working. One of the benefits is that you have a backup that way, and there's also the ability to undo. So every time you do a commit into the repository, you get a different version number. And now we're at revision 2. We can always undo changes on files and folders to go back to a previous revision. So we, in a sense, we have an infinite undo. That's one of the conveniences of using a source code repository. The other main reason, of course, to use it is to work together in groups. In this course, you're not sharing your repository with other students. You're not working with other students on projects, but you are in fact sharing it with me. So you and I will have joint access to your repository. So in that sense, we are in fact working collaboratively using the repository for that purpose. So now that you have this, we're going to go up into Lab 01, and then we're going to create with makedir the solution for the other exercises, which is P1_2 inside P1_. Notice that command completion doesn't work. If I hit tab twice, it shows 2 possible matches. I'm just going to add a 2 there. Hit enter. Now we're in here. And I'm going to copy. I'm going to use the CP command. That's copy. I'm going to go up a level and slash and go into P11/M arrow or tab. I'm going to make a copy of main.cpp from P11 and place it in the current folder, which is P12. Hit enter. Just check that with ls. There it is. So now I'm going to modify this. Here's the exercise P12, and this is almost the same thing. All we need to do is to change the second line. Hello, my name is Hal. It's the first line. What is your name? And let's go ahead and change that. Insert what is your name, and then we read the name, and then we say hello name, I'm glad to meet you. So it should be hello, comma, and then the name. So that's going to be user input, and we don't need this end line yet. So hello name. I'll do another one. I'll put a period there. See that? And then okay, so now what we'll do is we're going to copy this line, yank, YY rather, P for paste, go into insert mode, hello user input, and then we need a space here. What is it supposed to say? I am glad to meet you. I am glad to meet you. Hit escape. I'm going to save that. Now let's compile. C++ main, and let's run it. What is your name? Dave. Hello Dave, I'm glad to meet you. Okay, now we're at the point where we want to commit. And so first I will add, I'm going to paste in that command to ignore a.out. Of course we could just delete a.out as well, doesn't matter. And cd up, now we're in lab 01, we need to add, svn add, P12, and now they're scheduled to be added. Oh, look at this. This got scheduled to be added, so we don't want that to happen. So what I want to do, I think it's remove, svn remove, and that's P12 and a.out. Let's go ahead and remove that. Use force to override this. So I'm going to use minus force. Follow the instructions, and then we're going to commit the changes. Whoops, keep forgetting that. -M. Sorry, I'm in a hurry right now. -M, and there it is. We'll go ahead and look. Look at the folder. Now we see we have P12, and there it is, hello, and so on. So that's basically how you work. And so carry on and do the other remaining two problems.